So let's take a look at problem 12.1. So we have a canal that's 2 meters deep, 3 meters wide, and the water is flowing at 1.5 meters per second, as shown in the figure. If we toss a stone into the water, how fast will the waves travel upstream and downstream, and what's the Froude number? So looking at this, we need to find the right equation to use. So in the book, we developed the equation that said the speed of the wave was equal to the square root of g times y. So we can simply plug in the values. We know what g is, 9.8 meters per second squared. We know what y here is, that's depth of the water, which is 2 meters. So therefore c, the speed of the wave in the water, turns out to be 4.3 meters per second, using my calculator. 4.43 to be exact. Now that's the speed of the water in the wave, and so the wave is going to travel upstream and downstream, but the water is already flowing at 1.5 meters per second. So the upstream, the velocity upstream, we're simply going to subtract 1.5 meters per second from the 4.43 meters per second and have a velocity of 2.93 meters per second upstream. So in other words, you have, although the water is flowing down at 1.5 meters per second, the other wave is going to go flow back upwards at 4.43 meters per second. So you have to take the difference when it's going upstream. Now going downstream, the velocities are going to add. So going downstream is simply 1.5 meters per second plus 4.43 meters per second. So it adds up to be 5.93 meters per second. The last part of the problem, he wants to calculate the Froude number, so we have a formula for that. The Froude number is the velocity of the wave over c, or the velocity of the water over the speed of the wave. So and we have both of those numbers. That's 1.5 meters per second for the water flowing downstream, and 4.43, that's our c value. So it leaves a Froude number of 0.34. So he didn't ask this, but what do we know about this? So that if the Froude number is less than 1, this says we have subcritical flow. In other words, it's what's known as tranquil flow.